Hello. How's things? How's life? How's it going? Hope everybody is staying safe, staying well, staying healthy, staying busy, right, as things start to, well, I'm not going to say start to normalize it, but as over the weekend, as a few more things start to open up, still practice, proper hygiene, all that kind of fun stuff. Here we are going to get into looking at the female reproductive system. Right? If you remember, last class, we looked at the male reproductive system. Right? We finished up urinary system, and then we got through the male reproductive system. And if you'll kind of think back, I mentioned how there were many hormones which were kind of the same for both the male and female reproductive system. Right? Both involve levels of testosterone. They involve levels of estrogen, progesterone, obviously to varying amounts. Men have a much larger and higher amount of testosterone. Right? In conjunction with that, females have a much higher level of estrogen. So the entire purpose as to why that is, that's what helps to drive kind of the developing force, right? For instance, men. Right? Men on average are 20 to 25% just larger beings. Right? Part of that is we just have, men have a larger amount of muscle mass. That has entirely to do with the amount of testosterone that we have, right, coursing our body. It's significantly higher, and that's the big to do with testosterone, is that it stimulates muscle synthesis. In females, really the driving force is estrogen, progesterone. And the reason why that is because that helps to stimulate the ovarian and the uterine cycle. Right? The ovarian cycle is so the body can mature the egg for potential fertilization. That progesterone is the driving force behind cultivating, preparing, right, the uterine wall, right, the endometrium. That's the innermost lining of the uterus. That's the layer in which the blastocyst, again, we'll talk about that in a little while. But when the egg is prepared for implantation, right, when it's ready to, I'm ready to bore myself into the side of the uterus, it does so in a layer called the endometrium. There's a more specific layer that we'll get into later on, but the entire preparation or the entire purpose of that layer is to allow the potential implantation, and that's dictated, the thickness of that is dictated by estrogen and progesterone, but predominantly progesterone. So we can see, whoops, daisy. Okay. So in female anatomy, right, this stuff you would have covered in the lab, so I'm just going to briefly cover it here, but the urethra here, this is the bladder. Don't confuse this. That's the bladder. This here is the uterus, right? That's the uterus. And you can see coming up off of the uterus is the fallopian tube, or the uterine tube, or the oviduct. Right? Those are all the same thing. Leading into the uterus, right? We have this opening, the vaginal canal, opening up into the uterus. This first part, that's called the cervix. Alright, so go from the vagina, the vaginal orifice, into the vaginal canal, and then up into the cervix. Now, posteriorward, right, or kind of where are things in relation to each other, right, this all through here, right, this is the rectum. Right, this is the rectum. So you can see the rectum sandwiches the uterus between itself and the urinary bladder. Alright, so we're going to pull out the uterus. We're going to pull out, ovaries, and this is what it looks like. Right, here's the uterus, all through here, fallopian tube. Now it could be called fallopian tube, oviduct, uterine tube, all the same thing. Your choice as to what you want to call it. But you can see it comes out and it kind of hugs a hold of the ovary. And the whole reason why that is, inside of the ovary, right, this is where the egg, the oocyte, is going to mature. When it matures and it is ovulated, it gets dumped into the fallopian tube. So we have to make sure that the fallopian tube has the ability to kind of grasp and capture hold of this egg, and it does. Right, like literally the egg, the oocyte. Now I say egg, oocyte, same thing, interchangeable. Right, the more appropriate term is oocyte. Right, oocyte. You know, it's on 100 different slides later on. But literally, it is released from like the wall of the ovary. Like imagine if, you know, on your skin, you could just plop out an egg, or you could just pop out an egg out to, you know, but that was inside of your body, and it just literally got pushed out of your skin, and it fell to the floor. That is literally what happens with the oocyte. It gets pushed out of the ovary. We just want to make sure when that happens that it's directed into the fallopian tube. And that's why the fallopian tube, we see these little finger-like structures here. Those are called the fimbria. Literally, those kind of like grab a hold of the ovary, right? In between cycles, the ovarian cycle, right? The fimbria are kind of relaxed; they're not really adhered to the ovary. However, as the cycle, as ovulation approaches, that's where the fimbria literally act like fingers and kind of close up around the ovary. Therefore, when the ovary then ovulates the egg, right, that egg is actually diverted into the fallopian tube. All right. So the two cycles, right? I kind of mentioned these a second ago. We see the ovarian cycle and the uterine cycle, right? The ovarian cycle, preparation of the developing oocyte for fertilization, and yeah, preparation of the developing oocyte, which is developing because of the fact that females are born with all of the eggs they are ever going to have, right? Females, you know, they're born with around 400,000, right? More than enough eggs, right? You will never need to mature that many, unless you live to be the age of like, I don't know, 4,000, right? So you would never need that many. So those eggs, those oocytes, developed while you were in utero, right? If you're a female, right? So when females are in the womb, right, when they themselves are a fetus, that's when they develop the eggs that they are going to use later in life, you know, when they begin to ovulate. Right, so they're already there upon birth. It's now a matter of, now they need to become mature. That's the ovarian cycle. That's what occurs inside of the uterus. That is why women have the monthly, you know, their monthly cycle, right? Because of the elevation and decrease of certain hormones, and those hormones regulate the ovarian and the uterine cycle. So at the same time that the oocyte is maturing, right, at that same time, the uterus has to prepare itself for potential implantation. Fertilization, that's when, I'm going to draw an awesome sperm, right? That's when sperm gets into the oocyte. That's fertilization. Implantation, at the get-go there, it looked like something different. Right, here is fallopian tube, right? Fallopian tube, ovary, uterus. I'll take it. I'll take it. A little cervix, maybe a little opening. Kind of looks like a bull's head. Please do not read into that. I should have thought about that comment before I said it. Anyways, fertilization. That's when the sperm penetrates into the oocyte or the egg. Implantation is when that now fertilized egg makes its way all the way into the uterus and implants into the wall of the uterus. Right? That's implantation. Right? Literally just like you need to prepare the soil to plant a seed for a garden. Right? This is literally the exact same thing. Right? That's the uterine cycle. The uterine cycle is preparing the wall of the uterus for potential implantation. Woo! Alright, here are the hormones which are involved with that. So when we look, we see estrogen, we see progesterone. Now, as far as relaxin and inhibin, we'll talk about those a little bit later on. Right? They're not so important at the get-go. But we see from the hypothalamus, we have the release of gonadotropin releasing hormone that then comes down and stimulates the release of both FSH and LH. Cool. First, we're gonna ignore about LH's existence for a moment. We're just gonna look here at FSH. FSH comes down, and we see FSH is going to stimulate the follicles. So inside of the ovary, the purpose to the ovary is to be able to mature the oocytes with inside of it. When I look at this whole structure, this whole thing here, yeah, my computer had a stroke again. I'm not sure why it keeps doing that. Okay. This here, that entire thing is called the follicle. Inside of the follicle, this wee little thing right here, that there is the oocyte, or the egg. So the oocyte is inside of the follicle. So as the follicle, or as we mature the follicle, so does the oocyte. So what hormone do you think is responsible for stimulating the growth of the follicles? Follicle stimulating hormone or luteinizing hormone? Anyone? Aha. FSH, follicle stimulating hormone. Right? Follicle stimulating hormone stimulates the follicles to grow and to mature. As that happens, the oocyte, or the egg inside of it, is also stimulated to grow. Now, the importance there, right, we can see estrogen, progesterone, relaxin, inhibin. Progesterone, relaxin, and inhibin, they are not always present. Right? Progesterone is always present, however, the amounts of them is drastically different. And the reason why that is, as the follicle, as it matures, as it grows larger and larger and larger, it is going to pump out estrogen. So as it gets larger, it pumps out more. As it gets larger, it pumps out more. As it gets even larger, it pumps out even more. Until there's kind of a threshold. About this line. Once we hit this line, this is when LH is stimulated to be released. So early on in the development of the follicle, right, when it's super immature, it's producing like no estrogen. As it gets larger, it produces more estrogen. Okay, it gets even larger, produces more estrogen. Gets even larger, produces more estrogen. Until, oh, hey, I've hit that line, I've hit that threshold. Now that is going to stimulate the release of luteinizing hormone. Now, since we have the release of luteinizing hormone, so if we follow this, luteinizing hormone, this is, we're going to ignore the corpus luteum for a second because that doesn't occur without ovulation. But the luteinizing hormone, that is the specific hormone which is responsible for ovulation. So around day 14 of the ovarian cycle, right? People always call it, the month, right? 14 days of the month, but 14 days of the ovarian cycle. Right around, give or take. Some women are very regular, right? It's like, hey man, I can tell you, I am 28 days to the T, right? My cycle is 28 days. I can tell you to the exact second it's going to, oh, then there it goes. It just began. Some women are not as cyclic, right? They are somewhere between, 26 and 34 days, for instance. And there's 1,000 different reasons as to why that can be. So we're not going to, later on at the end, we won't get to it today, but we'll talk about some of the different reasons, some of the different causes as to why the cycle might be much more specific for some and a little bit more varying for others. But regardless, it's the same hormones, right, involved with everybody. So that luteinizing hormone, that is what stimulates ovulation. And again, ovulation occurs right around day 14. It takes luteinizing hormone about a day to build up enough to where it actually causes the release of luteinizing hormone. I think I said that. I think I misspoke there. It takes around 24 hours, or no, it takes around, let me back up. I forgot what I had said previously. So as estrogen builds, once it reaches a threshold, that's when luteinizing hormone is stimulated. When luteinizing hormone is stimulated, when it's released, it takes around 24 hours for it to then actually cause ovulation. So if ovulation occurred at day 14, luteinizing hormone would have been released right at around day 13. So it takes almost a full 24 hours. And that's where, again, an example of an endocrine, of a hormone, for instance, how they can be so wide-ranging as far as their impact. Right. Adrenaline or epinephrine, that has almost an instantaneous effect. Luteinizing hormone takes almost a full 24 hours to have an impact. Right? Some hormones take a couple of hours. So again, just one example of the wide-ranging and varying effects of different hormones. Okay. Sorry. So that's ovulation, right? When the oocyte is ovulated. Well, if you'll recall, think back a second. Inside of the follicle here, right, this guy here, that's where the oocyte is. Awesome. Well, as it develops, it gets larger and larger and larger. The follicle gets larger and larger and larger, and it pumps out more and more estrogen. Once the follicle is ovulated, now let's try that one again. Once the oocyte is ovulated, which is what we see right here, the oocyte is ovulated, and then we have kind of this empty follicle. Right? We have this follicle which was mature. It had an oocyte, but now it's just empty. So it doesn't just go away. It's not just like an empty, useless wrapper. right? It's not like candy bar, Snickers. Oh, sweet baby, I'd kill for a Snickers right now. That or $100 grand. Oh my God, something about those two things, those two candy bars. Oh man, get me out of bed in the morning. But when there's that follicle, when the oocyte is released, right? Oh, sorry. The analogy I was using was a candy wrapper. Right? You take the candy bar out of the wrapper's now useless. The wrapper has no purpose. You throw it away. Hopefully, you're throwing it away. Better not be just be littering it on the ground. This is a one world, people, one Earth. But after you take out the candy bar, the wrapper's useless. Right? That is the complete opposite. Nothing could be further from the truth in regards to the follicle. Right? Once ovulation occurs, that now empty follicle is still of immense importance. Immense importance. Right? That follicle actually becomes something called the corpus luteum. That's what we see right here. Right? That's called the corpus luteum. Again, that's the quote unquote the empty wrapper or the empty follicle. That's what it turns into once ovulation occurs. And you can see the corpus luteum is going to secrete progesterone, it's going to secrete estrogen, relaxin, inhibin. Right? It's going to release all of these different hormones. Right? Progesterone, yes, it works alongside estrogen, absolutely. Right? But progesterone, we see, is primarily responsible for preparing the endometrium for implantation. Something else we can see, something called relaxin inhibits contractions of the uterine smooth muscle during labor, increases flexibility of pubic symphysis, and dilates the uterine cervix. Yeah, right. Relaxin early on helps to prevent smooth muscle contraction of the uterus, and that kind of makes sense. Right, when we want to, it's much easier to hit a target which isn't moving. Right, not that the uterus is moving, but my point is if the uterine smooth muscle is contracting, it makes it immensely difficult for implantation to occur. Think of it, right? As just as where smooth muscle contracting in the GI tract caused that food or that bolus to move from the esophagus down into the stomach, for instance. Obviously, that's kind of something which occurs at the end, right, when we're talking about delivery. But even minute uterine contractions, right, even minute amounts of even smooth muscle contractions that you wouldn't even be aware of can prevent implantation. Now, before we go on into the specifics of the ovarian cycle, the specifics of the uterine cycle, I just want to look at the kind of some of the functions of estrogen, some of the functions of progesterone, some of the functions of these hormones. Now, I mentioned, right, progesterone works alongside estrogen to prepare the endometrium for implantation. Right? By and large, that's progesterone's responsibility. It prepares the mammary glands to secrete milk. So very, very kind of reproductive centric functions. Estrogens work outside of that a little bit as well. We see promote, develop the female reproductive structures, helps eventually cause the release of luteinizing hormone. But we see many of those feminine sex characteristics, right, that we see, right, development of breasts, for instance, that's all driven via estrogen, right, increase protein metabolism or anabolism, lowers blood cholesterol. We can see moderate levels inhibit the release of gonadotropin-releasing hormone, FSH, and LH. Yeah, even in this is going back to chapter 6 from last semester, so undoubtedly, I'm sure you're still, still going over that stuff and you're still refreshing yourself. But estrogen, right? That's one of the major potent stimulators of skeletal tissue, right? A skeletal growth. Right? It helps to increase the absorption of blood calcium. It helps to stimulate the osteoblasts, and more specifically, it helps inhibit osteoclasts. This is why menopausal women, they have a fraction of the estrogen that they have earlier in life. It's not that they don't have any. Right? Menopausal women still have some. Their adrenal glands can produce it. But when they have gone through menopause, their ovaries have shut down, their ovaries have waved bye-bye. They're like, all right, I'm peacing out. I'm going on vacation, wherever it happens to be. And they're no longer pumping on estrogen. Well, estrogen helps stimulate muscle synthesis. It helps stimulate bone growth. So if I'm menopausal, not me, I wouldn't ever be. Well, once in a while, sure, I'll be menopausal, I don't mind. But if estrogen stimulates bone growth, all right, well, if I'm postmenopausal, I don't have near the estrogen levels, so my bone isn't being stimulated to grow. All right. Secondly, if I'm not stimulated to produce muscle, well, if you recall, one of the main driving forces behind bone growth is the amount of force you're applying to the bone. So if my bone is already not stimulated to grow, and if I'm producing less muscle to apply less force to the bone, you could just see that's like I say trifecta, that's only two, a difecta, a perfect storm as to why women, especially menopausal, postmenopausal women, are at such a substantial increased risk of developing osteoporosis, especially compared to that of men. Right? Men, we've never relied upon estrogen as being the primary driving force behind bone development and muscle development. Right? Some of the other things that you see in menopause, right? And the reason why I talk about menopause is because if I describe some of those symptoms that arrive from the lack of estrogen, obviously the opposite would be true because of the presence of estrogen. But this is why menopausal women, right, postmenopausal women, why, right, they complain about like dry skin, dry brittle hair, brittle nails, right, dry eyes, painful intercourse due to vaginal dryness. Estrogen helps to stimulate the estrogen has a direct impact in the health of a variety of mucous membranes. Right? So those mucous membranes, again, lining certain parts of the skin, within the eye, within the mouth, lining the vaginal orifice or the vaginal canal. Right? That's why women, menopausal women, complain about kind of just dryness. Right? That's the reason why, because without the presence of estrogen, they have a reduced stimulation or a reduced ability to produce the wide-ranging, mucus that the body requires. All right. So, with the ovarian cycle, we're just going to kind of go through and look at what the follicle looks like. So, as I mentioned, right, I gotta stop saying right. It's driving me nuts. It's driving myself nuts. So, the primordial follicle, this here, this is present from utero. This is in the fetus, right? If you were a female, this primordial follicle, this was present in utero as you were a fetus. Even the primary follicle was present. Right? In later parts, right? Early adolescence. We don't start getting into the secondary follicle. We don't start getting into the mature follicle until ovulation or until the ovarian cycle begins. Right? And that is right around what used to be 13, 14 years of age, 13 years of age Now it's getting closer to 10 years of age for a myriad of reasons, right? But when, the period starts, right, that's when the ovarian cycle begins, right? That's when that maturation process occurs. And again, that maturation process, that is the maturing of the follicle. Right? So FSH, the presence of FSH stimulates the follicles to develop. So the primordial follicle develops into the primary. All right, the primary follicle then develops and matures into the secondary. Cool. The secondary eventually matures fully and becomes what's called a mature follicle or a Graafian follicle. Now, from like here, well, let's get all this stuff off the screen, make it a little bit easier to follow. From essentially like here, yes, I'm kind of dividing the primary follicle a little bit this way. That doesn't occur until, call it 12 years of age, right? Until the ovarian cycle actually begins. So, I say 12-ish. All the rest of this occurred prior, right? Fetal development, adolescence, right? That's when that occurred. Okay. So you can see how the follicle's teeny tiny, and it's getting larger and larger and larger and larger. As it gets larger and larger and larger, it's pumping out more and more. What hormone? Anybody remember? Estrogen. So just look at what follicle do you think is pumping out more estrogen? This one? Or this one? Oh, obviously, this one. Right, so yeah, that as the follicle develops, okay, so this one pumps out estrogen. This one, it's triple the size, so it pumps out triple the estrogen. I don't know if that number is specifically accurate, right, but it pumps out significantly more estrogen. As the follicle develops, it produces greater amounts of estrogen. Just keep in mind that estrogen is what's going to help thicken the endometrial wall. You have to prepare the soil when you want to plant seeds. Right? I will be planting a bunch of seeds in my garden. I'll be planting an entire mint plant. My wife may or may not have a slight infatuation with mojitos. By slight infatuation, I mean she has an obsession with them. Pretty sure it's the only reason she married me was because I could make one. Anyways, I don't know. We'll find out. But anyways, be planting the seed. Right? You have to prepare that soil. So that's what estrogen allows for. That's what it stimulates, is the actual preparation of that endometrium. Okay. So estrogen's pumped out, preparing the uterus, while at the same time FSH is still being released, and it's still stimulating the development and the maturation of the follicle. Eventually, the follicle becomes fully matured, something called the Graafian follicle, and we can see the oocyte is flushed out. It's ovulated. Cool. When that happens, next, right, this empty follicle, this wrapper, you can see it starts to degrade, right? But it doesn't, right, as it's degrading, its function is still immensely important. Remember the corpus luteum? This is what's going to start to pump out progesterone. This might be the longest word I've written. Kind of regretting it. There. Progesterone. Oh, thank God I spelled that correctly. Oh, that was painful. But that's what pumps out progesterone. Right, and that progesterone, again, that's what's going to prepare the endometrium. Or that's the progesterone, that's what's going to maintain or sustain that prepared endometrium. estrogen thickens it. Once it's thickened, now progesterone has to maintain the garden. It has to go through, it has to weed, it has to hoe the soil, right? Cultivate the soil, right? Ensuring that the soil is healthy, making sure that the soil is well maintained. Okay. So looking at the actual follicle, right? So if we kind of come way up in here, if I take this guy, we see formation of gametes in the ovaries is oogenesis. Yeah, oo. It does sound ridiculous, I'm aware, right? Oogenesis or oogenesis. Genesis, generation. Yeah, generation of the egg, generation of the oocyte. That's oogenesis. In utero, we can see primordial germ cells migrate from the yolk sac to the ovaries. Divide, become oogonia. Oogonia divide into germ cells, which are surrounded by follicular cells, hence primordial follicle. Okie dokie. So, what happens? We are talking, again, when we say primordial germ cells migrate from the yolk sac to the ovaries, we're talking early on in fetal, in embryologic development. Right, we're talking very early on. Right, all of these different steps begin to occur. When we talk about germ cells, it's like, well, that's when something germinates. All right, the seeds for the mint plant or the cucumbers that we're going to plant. Well, the seeds have to germinate. Right, so think about it. They germinate from, right, that plant germinates from the seed. So when we talk about germ cells, now we're not talking about like bacteria and we're not talking about those kinds of germs, but the growth of different cells come from different what are called germ cells. Think of them as being primitive cells. You've heard of stem cells, right? They're, kind of on the same idea, same level as that. They're not the same thing. Right? Kind of on the same level as that, is that they are, think of them as being very immature cells, which can germinate, give rise to other cell types. So what happens is this, right, primordial germ cell, which will eventually become the oocyte, we can see, becomes surrounded by follicular cells. So as it germinates, as it begins to grow, follicular cells are going to begin to surround the oocyte. Well, as those follicular cells surround the oocyte, that's what then forms the actual follicle. Right? Like this whole thing is a follicle. Being primordial, it is super immature, and the reason why we came up with the name follicle is because these cells, right, this cell here, 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 all the way around, those are follicular cells. So we call this entire structure a follicle. Cool. So as FSH is released, the primordial follicle develops in the primordial follicle develops into the primary follicle, and so on. And as I mentioned, as the follicle develops, so does the oocyte inside of it, until the follicle is fully matured and ovulation occurs. Cool. So as it goes through, which you guys can just envision, right? As it goes from this wee little size and gets larger and larger and larger and larger, we're going to start to see different cell types, right? We saw with surrounding the primordial follicle, we saw the follicular cells, right? But as the follicle continues to develop, we're going to start to see other cells come into play. So as the primary follicle begins to develop, now we start to see the development of what are called granulosal cells. In through here. Now don't confuse this with the follicular cells. Out here, the theca folliculi. Yeah, as the follicle begins to mature, as it begins to develop, those follicular cells start to form a more kind of substantial layer. That's what the theca folliculi is. Right out in through here. Something else to pay attention to. We see the zona pellucida forms between the primary oocyte and the granulosa cells. This purplish layer here, zona pellucida, this layer, it's important now, but this is one of the layers that the sperm is going to have to penetrate through later on. Remember that enzyme on the head of the sperm? That's something called, if you recall, it was something called the acrosome. The zona pellucida, that's one of the layers that the sperm will eventually have to penetrate through. Primary follicle develops into secondary follicle. Right, so as we kind of progress through, we can see how this very primitive, very simple, right? We have the oocyte, and we have just a thin layer of different cells surrounding it. Okay. Well, the cells start to become a little bit more compact. Granulosa cells start to appear. The theca folliculi begin to actually form a substantial layer. Then as the secondary follicle develops, so again, more and more maturity is occurring. But we can see some other things start to form. All right, the theca folliculi starts to have different layers. The theca externa, the theca interna begin to form. But really, what I kind of want to look at is this here. You might say, "Oh, it's just empty." Okay, there's nothing there. You're correct. It's just fluid. That's it. Just fluid. Okay. Excuse me. I guess you don't have to go do this. We've all flushed a toilet enough in our lives. But there's water in the basin. You do your business, and then you flush the toilet. And hopefully you haven't eaten Taco Bell. Actually, if it was Taco Bell, it would easily run through easily run down the drain. If it were whatever, you just ate like 25 pounds of cheese, you're all bound up. Right? So hopefully when you flush that toilet, all that water flushes what you ate down the drain, right down the toilet. This exact same thing happens with the antrum. The antrum is fluid filled. The antrum literally acts like a toilet as far as the fluid part of it. As the follicle matures, that the next picture we're going to see here in a minute, the antrum is very large. There's a large amount of fluid inside of the mature follicle, and the reason why that is so it can ensure that it flushes out the oocyte, i.e., ovulation can occur. Because if there wasn't this fluid-filled chamber, and if the follicle ruptured, and if there was no fluid inside of it, the hell would stimulate the oocyte to leave? Nothing. Just like if there was no water in the basin of your toilet. You do your business, you flush the toilet. If there's no water, your business isn't going anywhere. It's staying right there. So the antrum, even though it's just fluid, it's just a fluid-filled pocket, it is still immensely important. So some other layers we see, right, we continue to see the zona pellucida. Something called the corona radiata starts to form. You'll see that a little bit more pronounced in the mature follicle or the Graafian follicle. But really, here what I want to look at, right, throughout these follicular cells, right, this layer called the theca folliculi, you can see this is the layer which is going to predominantly produce estrogen. And you can see how this is a thin layer, really composed of not, I could, 1, 2, 3, 4, 5. I could count these cells. Maybe there's 30 of them in this example, in this image. Well, now you can see, oh man, they're substantially greater. It's much, much thicker. Right? This is as the follicle's gone from primordial into primary. Now you can see that layer's gotten even thicker. So as that layer gets thicker and thicker and thicker, gets more and more cells, it produces greater number and greater levels of estrogen. That's why as the follicle develops, it produces greater levels of estrogen. That comes from the theca folliculi, because of the fact that those follicular cells which make up the theca folliculi, those are the cells which are actually producing the estrogen. Now, do not confuse, right, these follicular cells with the follicular cells of the thyroid. And they, oh, those are the same thing. They're follicle cells, follicle cells or follicular cells, excuse me, but they're very different. Right? Hopefully your thyroid gland is not producing estrogen. That'd be odd. Right? But just like, oh, your gastrocnemius muscle and your biceps brachii muscle, they're muscles. Yeah, they're the same. They're both muscle, but they're both very different function. Same thing here. Right? These follicular cells surrounding these follicular cells making up part of the follicle are very different from the follicular cells which make up the thyroid follicle. So again, don't confuse those. So here, right, because once the oocyte is ovulated, once it's eliminated, it's done developing, right? And even just before that, right, the oocyte is not ovulated until it is matured, until it is ready to go. So, this we're going to ignore for a minute, right? Because that part, that's where it's no longer, right, maturing. If remember, 10 minutes ago, when I had drawn, I erased it. That's okay. I had drawn a kind of a line saying about here, right, from the age of 12 years of age and on, right, when the ovarian cycle occurs onwards. This is what occurs later on in life, right, once puberty's hit. Everything before this occurs in utero, adolescence. That's what we're going to take a look at right here, where you can see the primary oocyte. So the primary, right, the primary oocyte, right, that's already present. That's already occurring that's already present in the fetus. That's already present in utero. Right? And it's present within the primordial follicle. Now, one thing to not, right, you're probably already confused by it, that's why I'm going to address it now. I get that there's primary oocyte, primary follicle, secondary oocyte, secondary follicle. It would be very nice and very convenient for the primary oocyte to correspond to the primary follicle. I agree 100%. However, that's not the case. A primary oocyte is still present in both the primary follicle and the secondary follicle. The secondary oocyte does not occur, does not appear until the follicle is mature. Let's say that again. The secondary follicle contains a primary oocyte. The secondary follicle does not contain the secondary oocyte. When the secondary oocyte appears, that means, hey, I'm now mature. I'm 18 and I'm ready to go out into the world. Right? Although my kids are 7, they're like, yeah, hell with this, I'm out of here. But when the secondary oocyte appears, that's when it's ready for ovulation. So that appears once the follicle is mature. So don't think that, oh, if he's talking about the secondary follicle, he must be referring to the secondary oocyte. No, that unfortunately is not the case. So the primary oocyte, you can see the primary oocyte, that is present in, as you know, in fetus, in childhood, before any sort of follicular development, even into puberty. Right. When the ovarian cycle begins, that's when that primary oocyte continues its maturation. That's when it continues. Now, when I say that maturation process that we're talking about is something called meiosis. Right, that's the maturation process I've been referring to. Right, that meiosis, that occurs, that begins as a fetus. Get some of these off of here. Right, that occurs when you are a fetus, if you're a female, right? That occurs, that begins in utero, right? Right here. That's where it begins to occur as a fetus. In early childhood, adolescence, not much is going on. Once puberty is hit, menstruation begins, the ovarian cycle begins, that's when the next step of maturation or the next step of meiosis occurs, and the cell further develops. The reason why it can further develop is because of the development of the follicle. As the follicle develops, it pumps out more and more estrogen. That helps to develop the oocyte, or that helps to develop the uterus, the endometrial wall, but that's also what's going to help stimulate and mature the oocyte, the egg. Right, so that meiosis, that division, that's already begun as a fetus, and then it's just kind of put on hold for years. Right, that's literally put on hold for 10, 12 years until menstruation actually occurs, until the ovarian cycle actually occurs. And it continues until menopause. So, you know, anywhere from, in the 50s, just call it the 6th decade, right? Somewhere in that vicinity. All women are a little bit different. But that continues, right, every month. Now, there are birth control methods. There are methods which can impact this, the function of this cycle regarding ovulation. We won't get to it today, but next class we'll get into looking at some of those different methods and some of the ways that we can alter and affect the development of these oocytes. But when we talk about, right, the oocyte, right, how it develops, how it matures. Let me get this off of here. How I mentioned, right, the secondary oocyte, we can see how, as it's ovulated, right, eventually and potentially, fertilization might occur. If that occurs, that's when something called a zygote is going to form. We're going to look at all this development, the structures, the potential, what happens to this oocyte if it becomes fertilized, how does it become fertilized, how does it implant. We will look at all of that. We probably won't get to it today, we'll probably get to it next presentation, next lecture. But at the point of ovulation, like when this oocyte is ready to be ovulated, when it's ready to go, this is what the follicle looks like. You can see the size of the antrum. It's got massive. Right, there's a lot of water in the basin of the toilet, if you will. So it's mature, or it's called a Graafian follicle. Either one, your choice. whichever one you want to call it. But at this point, this is when the outer layer ruptures and the oocyte is flushed out of the mature follicle. When it's flushed out of the mature follicle, that is ovulation, and we want to make sure that that secondary oocyte gets flushed into the fallopian tube. So what caused that? What actually caused this ovulation to occur? We covered it half hour ago. Something called luteinizing hormone. Remember the theca folliculi, those cells, all these cells surrounding the outer perimeter of the follicle? That's the theca folliculi. We can see it secretes hormones, predominantly estrogen. All right. So early on in the cycle, let's call it day 0, because it can't get any earlier than that. We can see there's a slight uptick of FSH. Now, one thing we'll notice, there's never this huge spike of follicle-stimulating hormone. Nothing like that. We don't see any spike in follicle-stimulating hormone comparative to estrogen, LH, progesterone. Nope, don't see any of that. But early on, FSH is released, and that begins to develop the follicles. And remember, as the follicles develop, they pump out more and more and more estrogen. As they pump out more and more and more estrogen, that's what in turn causes luteinizing hormone to be released. Luteinizing hormone is released. It takes around a day for it to actually then cause ovulation. Cool. Keep in mind, when the oocyte, when that secondary oocyte is ovulated because of LH, that empty follicle, right, the follicle which did have that secondary oocyte in it is now empty, it becomes the corpus luteum. It becomes the corpus luteum. The corpus luteum, and we can see that develops right around day 12-ish. That's what begins to pump out progesterone. Now, one thing we can see is progesterone will naturally just start to drop. This is the normal progression of hormones in the female. In females. Right? FSH, LH, progesterone, everything is relatively low. Right? Now FSH, this is elevated for FSH. Right? FSH levels never reach great heights. But at the beginning of the cycle, everything is just decreased, very low levels. As the cycle continues, a week in, you can see estrogen starts to elevate around a week in. And around 2 weeks in, that's when estrogen is at its highest level. Same thing with luteinizing hormone. Luteinizing hormone, you can see, there's a range from about day 10 to about day 16 to 17 where it's elevated for only about 5 days. And really, as far as its actual elevated levels, we're looking at a 3-day window, right from here to here, right? So pretty narrow. All right. Then in the last 2 weeks, right, day 14 to day 28, really day about 24, that's where we see progesterone is elevating, and then it's at its highest level. This is the normal hormonal progression, the normal hormonal pattern in a non-pregnant female. The reason why I say non-pregnant looks a lot different than this when women are pregnant. for obvious reasons. Right? There's now a leech inside of you that needs to grow and flourish, so hormonal levels are going to fluctuate and change. Most specifically, progesterone, but we'll get there in due time. To keep in mind, so as I just mentioned, right, these hormonal levels look different when we're pregnant. But in order to get pregnant, the uterus had to prepare. The uterus, the wall of the uterus had to prepare for implantation. Alright. So the whole time while oocytes and follicles have been maturing, the uterus has also been preparing, hence the uterine cycle. Yeah, at the beginning of class I had mentioned the ovarian cycle and the uterine cycle. They occur simultaneously to one another. There's no purpose to mature the oocyte if we don't at the same time prepare the uterus for potential implantation, right? There's no purpose to plant, there's no purpose to go and buy a pack of seeds at the store if I don't simultaneously prepare the soil for my garden, right? If I buy the seeds, I had to prepare the soil to then plant the seeds. If I buy the seeds and then I don't prepare the garden for 6 months, the hell was the point in that? Now the seeds are no good. So at the same time as the ovarian cycle, as the oocyte is maturing, the uterine wall has to quote unquote mature as well, or has to thicken and prepare for that potential implantation. So there's 3 layers, right? The perimetrium, the myometrium, and the endometrium. Perimetrium, that's the outermost layer. Right, so if I were just to, within the pelvic cavity, if I just poke the uterus, that part I'd be poking, that's the perimetrium. The myometrium, that's the muscle, right? That's the wall of the myometrium. The endometrium, that's the real metabolically active. That's what we've been focusing on. That's what we've been talking about as far as, the uterine cycle developing, because the uterine cycle doesn't really involve the perimetrium and the myometrium, right? The perimetrium and the myometrium don't change a whole lot, cyclically. It's the endometrium which changes on a weekly basis, right? As once menstruation occurs, once the uterine cycle actually occurs. So we can see something called stratum bacillus and something called stratum functionalis. Okay. Stratum bacillus, the layer that is layer that's permanent and gives rise to a new stratum functionalis after each menstruation. Yeah, so each month, I'm going to start at the end and work backwards. Right, when menstruation occurs, what that actually is the stratum functionalis shedding off. Right, so we talk about like blood or like period blood, right, menstruation. What that is the innermost lining of, it's a part of the innermost lining of the uterus that is shedding off. The specific layer which is shedding off is something called stratum functionalis. We see layer which is shed each month during menstruation. The stratum bacillus, that does not shed. That's permanent. That layer's there. That's the layer which gives rise. That's the layer which multiplies and then adds to the stratum functionalis. It's the stratum functionalis which is going to thicken and shed each month if pregnancy didn't occur. We can see it's this layer which implantation would occur within, right? It's the stratum functionalis, which is where the implantation would occur. So we think about it, why does it shed? Right? Why would the stratum functionalis shed? Alright. Let's think about it. Let's just look at this. Just take 15 seconds. I'm gonna take a 15-second break. I'm gonna pour myself some more coffee. Take 15 seconds and just look at the different hormones and think about what hormone might be most responsible for the shedding of this stratum functionalis. And if you heard some liquid, don't worry, that wasn't me peeing, that was me actually pouring coffee into my cup. And before you're like, what is he just sitting next to his coffee pot? Don't judge me. We all have our shticks, we all have our thing. Leave me alone. Alright. So, we can see FSH, LH, estrogen, progesterone, they're all very low. So let me draw this, maybe it'll help. This here, that's where ovulation occurs. I'll write it all out. Wow. Something here to here, right? Depending on the day, I'll just kind of do one of these things. Somewhere in here. That's where ovulation is going to occur. Cool. Menstruation. Right? Ballpark figure, right? Within a day, right? This is where that's going to occur. I'll just write mens, right? Menstruation. That's when that's going to occur. All right. So ovulation occurs here. Progesterone elevates. Now, luteinizing hormone is already low, right? It's low way back in here. So I don't think it has anything to do with luteinizing hormone dropping too low, right? If low levels of luteinizing hormone cause menstruation, I would expect the menstruation to occur way over in here. I didn't see that. Okay. Maybe it's low levels of FSH which cause menstruation. Yeah. No, because if that was the case, I would see it somewhere like in here or here. So that's not the case. How about estrogen? Well, estrogen's lowest like here. No, the only thing that we see what drops off is progesterone. And that's because it's progesterone's responsibility to maintain that stratum functionalis. Right, this layer here, this layer which thickens as the uterine cycle occurs, progesterone is the primary responsibility to maintain the thickness of that layer. It's progesterone's responsibility. So if we want to maintain that layer, or basically if we can impact progesterone's stability or progesterone's, right, if we can maintain progesterone's elevated levels, we will then in turn maintain the stratum functionalis. And that is the idea of pregnancy and the different hormones which are present. All right, we'll look at those in a minute. So I'm going to look at these together. So here's the uterine cycle, here's the ovarian cycle. You can see as they occur simultaneously, right? Right, these, right, the primordial follicle, right, half of the primary follicle, again, that's all like early on, like in utero, right? And really, actually, it's this here. Right. This is like in utero, like when you were a fetus, right? If you happen to be female, right? Okay. All the rest of this stuff: primary follicle, secondary follicle, mature follicle, ovulation, corpus luteum. When all of this occurs, this is what is simultaneously occurring in the uterus. All right. So, as the primary follicle pumps out estrogen, as the hypothalamus pumps out gonadotropin-releasing hormone. As the hypothalamus pumps out gonadotropin-releasing hormone, that stimulates the release of FSH. FSH then is what causes the follicle to mature from primordial to primary, from primary to secondary, from secondary to mature. And when that happens, it pumps out greater levels of estrogen. Hence the reason why this is what you see. You see this proliferation, you see this thickening of the endometrial wall. Cool. Once ovulation occurs, we still have this remnant of a follicle left. That's what becomes the corpus luteum. And now the corpus luteum, it pumps out progesterone and estrogen, but progesterone, that's the real big one. Because progesterone is what helps to maintain the thickness of the uterine wall. Right? It's progesterone's responsibility. If progesterone drops, if progesterone levels drop, what happens? Menstruation occurs, because elevated progesterone levels are what help to maintain the stratum functionalis. And recall, a minute ago I had mentioned, if implantation were to occur, it occurs in the stratum functionalis. But what happens to a seed that you plant in soil if it's a real hard rain and all that soil gets washed away? Oh, so does that seed that you just planted. It gets washed away as well. That's why we have to be able to maintain elevated levels of progesterone early on and throughout pregnancy, because that's what helps maintain the stratum functionalis, because that's the layer which the implantation actually occurred. Now, throughout pregnancy, that the name of that layer changes, right? It becomes different layers, decidua and things like that. But we'll talk about that a little bit later on. But from that point, here I'm going to pause, and we're going to pick up with this on the next class. But we're going to look at what actually occurs when ovulation takes place. Right? So once ovulation takes place, and as that occurs, I'm going to tie into potential fertilization, because that is the entire purpose to ovulation, right? Is that oocyte being released into the fallopian tubes for potential fertilization, right? That's the purpose to that oocyte being released. So next class, that's what we're going to pick up on. That's what we're going to look at, is the changes in the fallopian tube, the changes in the oocyte, and what would occur during fertilization, and how that fertilized egg travels down the fallopian tube and eventually implants itself potentially into that stratum functionalis of the uterus. So that's what we're going to pick up on Thursday. So everybody have a fantastic time. Right? Enjoy yourselves. Find some quiet time. Stay healthy. Make yourself some white chocolate macadamia nut cookies. That or some oatmeal raisin cookies. Either one would be fine. Preferably, make them both. We got nothing but time on our hands. Right? They are, oh man, oatmeal raisin. That's what I'm making today. So, anyways, folks, take care. If you have any questions, please shoot me an email, or remember, email. You have my number as well. Get a hold of me somehow, right? If we have to, we can definitely. A number of you guys, I have a number of you, have emailed me with questions. Thank you. It's fantastic. For those of you that haven't and you have questions, please email me. And if email won't suffice, we can even do Zoom sessions, right? I've Zoom session with a few of you. So, anyways, take care. If you have any questions, let me know.